Welcome to College Algebra. This is section 4.3. We are solving rational equations. Rational equations just mean that my equation has a denominator to it. In this case, in problem 1, all of the denominators are numbers. We're going to see soon that we might have variables down there. All right, so our strategy in solving these is going to be to get rid of all the fraction parts. And I get rid of it by multiplying by something. Because if I multiply by the correct thing, 16 will cancel, 12 will cancel, and so will 3. So how do I find that thing? All right, well, here it is over here on the side. I take each of my numbers, 16, 12, and 3, and I prime factor each one. So 16 is 2 times 2 times 2 times 2. 12, 2 times 2 times 3, and 3 is just 3. Once I prime factored it, I go look. My lowest prime is 2. The most number of them is 4 of them. See, there's 4 there, 2 there, but the most is 4. So I grab 4 of them. What about the 3, my next prime? Well, there's only 1 3, and so multiply by 3. And so, if I multiply that out, I get 48. And that's the number that I need to multiply by each of the pieces. All right, so you can see here, I'm taking 48 and I'm multiplying it by every piece in the problem. Well, 16 will go into it 3 times, giving me 3L. 12 goes into it 4 times, giving me 4 times L minus 7. 3 goes into 48 16 times, giving me 16 times L plus 6. All right, at that point, I just need to start distributing. All right, so what do I've got? Minus 4L. A minus 4 times a minus 7 is a plus 28. 16L, 16 times 6 is 96. And let's see, I can combine these two, the 3L minus 4L, to give me a minus L. And now I'm going to get the L's together and the numbers. So I'm going to move this minus L to the right, making it plus. Moving this 96 left. All right, and so when I subtract, I get minus 68. And to clean this up, I simply divide both sides by 17. And I get that my answer for L is negative 4. All right. In question 2, we're not solving anything. We're just trying to figure out what are the restrictions on X. What do they mean by restrictions? Well, remember, 5, as an example, over 0 is undefined. So I don't want any of these bottom parts, or denominators, I don't want them ever to calculate to be 0. So, well, when would it happen? Well, x plus 8 being 0 would say x has to be minus 8. X plus 2 equals 0 says x equals minus 2. So my restrictions, or bad answers, would be minus 2 and minus 8. Other values for x are okay, just not anything that would make the bottom calculate to be 0. All right, in question 3, we continue that. So let's see. I've got 3 pieces. I got this 7x minus 5. I don't want it to be 0. I don't want 4x to be 0. And I don't want 8 minus x to be 0. Well, when would all this stuff happen? Move the 5, divide by 7, so 5/7 is a bad number. Let's see here, divide both sides by 4. Okay, 0 over 4. Well, remember, 0 on the top is okay. I'm just trying to avoid 0 on the bottom. All right, so I get 0. And x minus 8 is 8 minus x is 0. I move the x and I get x is 8. So there are 3 numbers I would like to avoid. Question 4. All right, question 4. Notice this equation has numbers in the bottom, but it also has variables. So the first thing I'm worried about, since there are variables, are there any bad values? Well, let's see. Yes, 3 times 0 would be 0. 6 times 0, well, that's 0 as well. So the bad value is 0. If we happen to get that as an answer, I'm going to throw it away. All right, so next, I'd like to multiply by something that will make all 4 of these things cancel. What about the numbers? Got a 3, a 4 is 2 times 2, 6 is 3 times 2. So let's see. Well, got the most number of 2's, 2 2's, 1 3, and so I'm going to multiply by 12, but 12w because I want that to cancel as well. So the w's go, 3 goes into 12 4 times, 4 goes into 12 3 times, leaving me a 3w. Got a 6w here, all right, that goes into there 2 times 13 is 26. 3 goes into 12 4 times. I have a 4, a w, and a 2. So an 8w. All right, let me get the w's together and numbers together. So minus 8w minus 3w. 4 minus 26. All right, so I get a minus 22 equals a minus 11w. So divide by minus 11, and I get w equals 2. And that's fine. I get to keep that number because it's not the bad one, which was 0. Let's see, question 5. All right, so looking here at 5. I've got variables in the denominator, so I'm worried when that might be 0. Well, let's see, p plus 5 equals 0. I get p equals minus 5. All right, so I don't want to get that number. Well, I need to multiply by something, and there's only one thing down there, p plus 5. So I'm going to multiply p plus 5 by all 3 pieces. First piece cancels. Next one, nothing cancels. I've got 7 times this piece. And on the right here, all of it cancels, and I get a 9. All right, I need to distribute the 7, so 7p plus 35. Let's see, got a couple of numbers there. I've got a 2 and a 35, so that's a 37. Let me take the 37 to the right, and so I get 9 minus 37, which is minus 28. and then divide both sides by 7, and I get -4. -4 is okay. Remember, the bad one was -5. All right, so far so good. Question 6. Let's see. Well, question 6 has variables in all three pieces. This piece looks suspicious to me, like something is in common. All right, let me take a common x out. Oh, I see. I've got an x, and I don't want that to be 0. I don't want x minus 5 to calculate to be 0, and that would be at 5. Okay, so don't want those two numbers. And if I want all of this stuff to cancel, I need to multiply by x minus 5 times all three parts. In the first part, everything cancels and I get a -7. In this next part, x minus 5 cancels and I've got x times x, which is x squared. On the right, the x's cancel and I get x minus 5. All right, so let's see. Looking at that, well, I've got this squared thing, so I'm thinking, well, let me bring all of this stuff left. So I'd have an x squared, a minus x, a -7, and this -5 that came over is +5. And look, we have our friend, the quadratic equation. And so to finish the problem, I've got to solve it. Now, remember, we had 4 ways to solve them. You can pick whatever is the easiest for you. But in this case, I think factoring works. X times x is x squared. -2 times 1 is -2. And the middle and the outside does give me this -1. So set each part to 0, and I get answers of 2 and -1. We get to keep those because, well, they're good answers. The bad ones were 0 and 5. Let's see, question 7. All right, looking here at 7, I've got variables in all three parts. This guy looks like I should do something with it, like factor it. It is the difference of two squares, so it's going to factor as a plus and a minus. Let's see, bad answers. Well, -4 would be bad there, and +4 is bad there. So I don't want to get either one of those. All right, now since I want all of this junk to cancel, I am multiplying that stuff, all of it, by all three pieces. Yes, long, tedious, but it's what we need to do. All right, in the first part, let's see, p plus 4 will cancel, leaving me p times p minus 4. On this part, everything cancels, giving me a 32. And over here, well, nothing cancels, and I've got to multiply all that stuff out. Let's see, p times p squared minus 4p, got that, 32. Well, remember this stuff, when it was multiplied, was p squared minus 16. So let me distribute in the 3, and I've got 3p squared minus 48. All right, looks like we have some cleaning up to do. Let's see. All right, so since the p squared is here with a 3, I'm going to bring all of that stuff left. So what do I have? Let's say I got a 32 minus 48. This minus 4p is a plus 4p. And I've got a 3p squared minus p squared. All right, what can that be? Well, 3 minus 1 is 2. Got the 4p. 32 minus 48 is 16. But I'm noticing that I can reduce the numbers a little bit simply by dividing everything by 2. All right, those cancel. 2 goes into 4 twice. 2 goes into 16 8 times. Again, a quadratic equation. Your best two methods are going to be factor it or the quadratic formula. But it does factor here. P times p, p squared. 4 times minus 2 is a minus 8. And 4 minus 2p is the plus 2p in the middle. So grab each piece, set them equal to 0, and I get answers of 2 and negative 4. Let's see, what were my bad answers again? Oh, 4 and negative 4. Minus 4 is bad. It would make my problem undefined. So let us say goodbye to that number. So we only get one solution, namely p is equal to 2. And that concludes section 4.3.